Let's take a look at complex numbers. In the diagram in front of you, you see all of the real numbers that we've been dealing with so far in our studies. But now, what happens when I want to take the square root of a negative number? Well, and to this point, you don't really have a way of doing that. You see, if I were to take a 1 times 1, that would give me a positive number, and that's true of any number, right? A positive times a positive is a positive number. Well, what happens when I square, so this is basically saying 1 squared, what happens when I square a negative number? If I take a negative and I multiply it by a negative 1, well, that will also give me a positive 1. So a negative times a negative also generates a positive, and in this case we have the quantity negative 1, and we're squaring it. In both those cases, we end up with a positive number. So it is not real to conceive of the square root of a negative number. Now, that does not mean that we will never see in our studies of algebra the square root of a negative number. So we need a way we need a way to understand what happens, or how can we square a number and get a negative number. So we define another constant, and we'll call this constant I. And I is our imaginary number. And the thing about I, the technical definition of I, is a number that when you square it will generate a negative or a negative 1. So one way that you can conceive of I is to say the square root of negative 1 is I. See, if I take I and I square it, I will get a negative 1. Well, that's the definition of I. So to conceive of I, you can say, well, the square root of negative 1 here is also I. What we do when we define I is we introduce a whole new number into our ontology, and we say, well, in addition to the real numbers, we have this other set of numbers called imaginary numbers, and together the real numbers along with the imaginary numbers create the complex numbers. And we'll see what that means in a second. A complex number takes the form of a real number part plus an imaginary number part. So we can have a complex number that looks like 3 plus 2i. And let's take a look at, let's do this in a different color. And the way we can conceive of this is if I were to take a grid and draw my, say we'll do my real numbers in blue and my imaginary numbers in orange, then what happens is I will go to 1, 2, 3 on the real part and go up 1, 2 on the imaginary part, and I will have a point here that is described by the number 3 plus 2i. And actually, it doesn't work exactly the same as your Cartesian plane. The value, the actual value, is this distance here. It's the distance from the origin, from 0 real and 0 imaginary to that point. And we're not even going to get that far in this class. I just want to make sure that you understand the difference. So in terms of complex numbers, I can have complex numbers that are entirely real, say a number like 9 plus 0i, and we would normally just write that as 9. Whenever we see the number 9, it is 9 plus 0i. This is a real number. I can also have a number like 0 plus 2i, and again, this is going to be called an imaginary number. Imaginary because it has no real number part. It's only the imaginary number part. In this case, it's equal to, we could conceive it also as 2i. Or as an above, I can have a complex number which contains both a real number part and a complex number part. And it's important to understand the difference between those two, because when we start adding and subtracting complex numbers, you're going to have to segregate them.